Today we're going to learn Pythagorean theorem. Pythagorean theorem was founded back in ancient Greek times by a man named Pythagoras, hence the name Pythagorean theorem. Okay? He was playing or exploring with right triangles. Is everybody listening? What he found, everybody look at the bottom picture. He found that every time there was a right triangle, if you put squares on them. So everybody look at this square. This side length is 3. This side length is 4. This side length is 5. So if I have a side length of 3, then I have an area of 9. Yes? If I have a side length of 4, I have an area of 16. And if I have a side length of 5, I have an area of 25. What he learned is that it never failed if he had a right triangle, the two smaller squares will always add up to equal the bigger square. So 9 plus 16 is 25. And he just kept trying it and trying it and trying it, and he realized it worked every single time for right triangles. Make sense? So go back up to the top. In a right triangle, he named the sides. And he said, we're going to call the two sides that form the right angle legs. So here's your right angle. This is going to be a leg, and this is going to be a leg. Then he said the side across from the right angle, which is the biggest side, is going to be called the hypotenuse. I don't know why he came up with that name, but that's what he wanted to use. So you have this imaginary square over here, an imaginary square here, and the area of those squares are going to add up to equal the bigger square. The bigger square will always be the side that's attached to the hypotenuse. Now he wrote a formula for this using the variables a, b, and c, where the hypotenuse is always the c. The two legs, it doesn't matter which one is a or b as long as they're legs. So a and b. But you could put a and b here. You could switch it up. It doesn't matter. The formula is the area of this square. So if this was side A, how do you find the area of a square? Yes, but no. Give me more. Side times side. So wouldn't that just be if the side was A, how would I write that? A squared. So the formula is A squared plus, if the side is B, how would I find the area of the square? B squared equals the area of the hypotenuse, C squared. And that is the formula for Pythagorean theorem. Easy or hard? Easy so far. Okay. And it actually is super easy. So why did he figure this out, and what do we use Pythagorean theorem for? We use it for two reasons. The first reason is if you are given a triangle, but you don't know if it's a right triangle. And let's say you don't have something to measure the angle. You can tell if it's a right triangle by seeing if the Pythagorean theorem is true. So does everybody agree this looks like a right triangle, but there's no marking to say that is a right angle? So to see if it's a true right triangle, you would say, is a squared plus b squared equal to c squared? Yes or no? And you would fill these numbers in. Well, based off of the hypotenuse, which is always the biggest side, which one of these would be the hypotenuse? So that has to be the C. The other two, it doesn't matter what you do. Which one's A, which one's B. So I would say is 9 squared plus 12 squared equal to 15 squared. And I would just test it out. Is it yes or is it no? Will you put it in your calculator? What is 9 squared plus 12 squared? 225. What is 15 squared? 225. Since they are equal, this is a right triangle. So my answer would simply be yes, it's a right triangle. Good? All right, let's try the next one. Based off of Pythagorean theorem, which one would have to be the hypotenuse? Why? Because it's the longest side. So this would have to be the C. And I would say is 32.5 squared plus 39 squared equal to 48.5 squared. 32.5 squared plus 39 squared is 2577.25. And 48.5 squared is 2352.25. Do those equal?
No.
No. This is not a right triangle. Even though it looks like one, it's not one. Are we good on that part? Why else do we use Pythagorean theorem? To find the missing side of a right triangle. So let's look at the first example. The first example, we're going to solve for the hypotenuse. So everybody look. How do I know where the hypotenuse is? It has to be across from the... So this has to be side C. Does it matter which one of these I call A or B? No. So I'm going to call this one A, this one B. I write the formula down. A squared plus B squared equals C squared. Everybody should be writing when I'm writing. I now fill in what I know. Well, I know that A is 6, so 6 squared, plus I know B is 8, so 8 squared equals C squared. And now I simply solve it like an equation, a missing side. Yes, a missing variable. So what is 6 squared? 36. What's 8 squared? And 36 plus 64 is 100. Now, if you didn't know that, could you go put that in your calculator and say, what is 6 squared plus 8 squared?
Yes.
Yes. Now, right now, we have found 100 is the value of C squared. That is the area of a square over here. Does everybody see what I'm talking about? So the area of this square is 100. But we're trying to find the side length. So what would I do to this number? Okay, also, remember when I was telling you all the opposite of add is subtract, the opposite of multiply is
Divide.
the opposite of square is square root. So we would square root both sides. So just so you know, that's how you would find side C. And the square root of 100 is? The square root of 100 is 10. Are we okay? Now go to example 2. This time they give you the C. So here's the right angle. Here's the C. So this time we're going to solve for A or B. I'm going to call the missing side A. Write your formula down. A squared plus B squared equals C squared. Fill in what you know. Well, I don't know A, so I say A squared plus the B is 15, so 15 squared equals 21 squared. Now, solving this equation, I can't add because I have to get the A by itself, right? So how would I get the plus 15 squared to the other side? Minus 15 squared. You could square it first and then move it, but just save yourself a step and do it all at once. What is 21 squared minus 15 squared? Well, 21 squared minus 15 squared is 216. Now, I have not solved for A yet. I have solved for A squared. So what's the inverse operation of squaring? Square rooting. And the square root of 216 is 14.69. Now, on your assignment, you're going to be asked to round to the 10th place. What is the 10th place? The 6. So will it stay a 6 or will it become a 7?
7.
So my answer is 14.7. If you round wrong on your homework, or it's not homework, on your assignment, I'm counting it wrong. Okay? You are going to try these two on your own, and then you'll get your assignment. Remember to identify side C first. Check your answers with mine when you finish them. Guys, if y'all would pass the assignment down. Okay, I want you guys to look at the assignment. First of all, did anybody have questions on these two, or are we okay? Are we okay? Okay. So on your assignment, make sure you put your name on 1 through 6. All you're going to do is write yes or no. Okay, so you're just going to see if it makes a right triangle. On 7 through 12 and the back, you are solving for the missing side and you are rounding to the nearest. What does that mean? 1 decimal place. So if our answer is 45.92, then my answer would be 45.9. Make sense? Okay, you should finish in class. You should not have to take this home.